In today's class, you will be able to understand inscribed angle theorem and use them to solve problems. Well, so first of all, what is inscribed angle? Okay, and what is central angle? So I'll try to explain that part first. Let's say that this is the center of the circle, and you know that the line segment drawn from the center to the boundary, this is called as radius. So I'm taking two radii. The plural form of radius is radii. Therefore, this is bad. So let me take, okay. So this is radius. This is another radius, right? And these two these two radii are together making an angle at the center, right? So I call this one as central angle. This is the central angle. Next, inscribed angle, which is similar to this one. See that I'm drawing a line segment, and it is not the radius and this is not the diameter also. We call this as a chord, right? These two chords are making an angle on the boundary of the circle, right? This angle, I call this one as inscribed. This is called as inscribed angle. Okay. Next, the arc which is formed here, I call this one as intercepted arc. Intercepted arc. Now, really quick, let's have a quick summary of the points. If you are taking a circle, okay, in the circle, let me take that the center of the circle first, and next let me draw really quick few line segments. Oops, this is not a straight line. Okay, so this is the radius, and this is another radius. So the angle formed by two radii at the center of the circle, this is called as a central angle. This is called as central angle. Let me label this one as a central angle. This is central angle. And next, the arc made here, this is called as intercepted arc. Okay, and next one, let me take two more line segments. Oops, let me take two more line segments. This is a chord and this is another chord. Okay, and these two chords are making an angle here, not at the center. This angle is made on the circle. This is known as inscribed angle. This is known as inscribed angle. Okay, now if you want, you can perform this experiment. It does not depend on the size of the circle. If you want to take the small circle or maybe little medium size or maybe large circle, whatever the size you want, you can take. Okay, in these all, let me mark the center of the circle, center of the circle, and center of the circle. Okay, now draw the radius, and I'm giving you some 3 examples. 3 examples. And from the same points, which means here I'm taking the same points and I'm constructing now 2 cards. One is here and one is here. Again, as I told you before, it can be anywhere. The angle can be formed on the boundary. Do you see that it is not right above, but it is tilted to left side. It is tilted left side, right side, it doesn't matter. Okay, so for experimental purpose, if you want, you can take and draw this way and you can check. Okay, so this way, and next say that maybe this way and this way. Now take a protractor and measure what are the values. What is the central angle? I don't know what is the central angle here, but just assume that I'm using a protractor and I measured and I found that this is 92 degrees. And I measured this one and this one is 46 degrees. And the central angle I measured, I found that this is 60 degrees. And I measured the inscribed angle and I found that this is 30 degrees. If you want, you can do this experiment. This one, the central angle I measured and I found that this is 140 degrees, and the inscribed angle I measured and I found 70 degrees. So from this experiment, you can say that the measure of inscribed angle, equals to, please check that if you observe carefully, you see that this is 92 and this is 46. 46 is half of 92. In the same way, the central angle is 60 degrees and what is the inscribed angle means that is 30 degrees. And here the central angle in third case is 140 and the inscribed angle is 70 degrees. Actually, randomly some numbers I picked, but if you experiment, you will realize that half of central angle gives you the measure of the inscribed angle for sure. Okay. One more important thing is measure of the intercepted arc. You know what is intercepted arc, right? So here, what is the measure of intercepted arc means that is same as the central angle. Therefore, the intercepted arc measure is same as the central angle. So this is also 140 degrees. Okay, don't forget this one. Don't forget the measure of intercepted arc is same as the central angle. Okay, so let's take quickly a couple of examples. Let's say that in this question, here this is B, this is D, this is C, this is A. Okay, let me copy this one so that we can reuse it again. Right. Measure of central angle. Let's say that measure of central angle is given that 96 degrees. And what is the value of DBC? So what's the value of DBC? So first of all, you have to remember the terms. This is the central angle. So angle made at the center by 2 radii. This is the central angle. And this is inscribed. You have to memorize these terms. So this is inscribed angle. Okay, and also you have to remember the rule. The rule is inscribed angle equals to inscribed angle equals to half of central angle. In math, you have to remember two things. One is you have to understand the concepts, and the second thing is you have to remember the procedure. Okay, so here I don't know what is the measure of the inscribed angle, so let it be x degrees, and half of what is the central angle means. Do you see that it is 96 degrees? So you have to plug in the values exactly where they are. So here 96 degrees. So half of 96 degrees, you may grab a calculator and compute what is half of 96. That gives you 48. So the measure of this one is equals to 48 degrees. Any questions? Let me take another question which is similar to this one. This time this is a little upside down. In the previous one I found what is the inscribed angle, and here let me make a question that here the inscribed angle is given as some, say 36, oh not 36, let me make it as 47 degrees, and what is the central angle here. Okay, again don't forget, you have to understand and remember this one. The angle made by these two radii is the central angle. That's what is missing here, and you are asked to find. And the angle made by two chords on this circle is it is inscribed angle. This is inscribed angle. So let me write quickly. The rule is inscribed angle equals to half of central angle. Half of central angle. Now we have to plug in these values. You see that inscribed angle is 47, so it goes here. So 47 degrees equals to half of the central angle. I don't know what it is. Therefore, let me take x here. Half of x. Okay? Half of x. You know how to isolate the variable. So if I take times 2 on both these sides, so 2 times half, that gives me 1. 1 times any number or any value, that gives me back the same. So 2 times half, that is 1x or x. 2 times 47, it's 94. The value of x is 94. You may say that this is the central angle, which is 94 degrees. So just now you computed the central angle value, which is 94 degrees. Okay, any questions on this? Well, look at this question. Find the indicated measure. I see that RS, this is the arc value given, which is 48, and the inscribed angle is given as 50 degrees. Let me use a different color. Here the inscribed angle is given as 50 degrees. Okay, the question is what is the measure of angle T? So the question is what is the measure of angle T? Let me label this as x degrees. Okay, now at this point you may forget the information which is not related to this question. So what I'm doing is I'm deleting this part. because this is no way connected to find the value of x, right? Okay, so let me put it back. Okay, or else let me copy this one. Just I'll explain the method, then later on I will delete the unnecessary part. Okay, so here, as I told you before, let's say that while computing the value of x, this portion is not required. Earlier I mentioned that the central angle value and the arc, these two measurements are the same. Okay, do you remember earlier I mentioned this point that the value of intercepted arc and central angle, these two are the same. Therefore, the central angle is to be taken as 48 degrees. And what is the value of x means? Now it's a very simple task now, because we know that inscribed angle equals to half of the central angle. So in this question there are two parts, but if you take as a whole it really confusing. But if you separate them this way, it becomes easy. Now, what is the central angle measure means? It is 48 degrees. 48 degrees. So, what is half of 48 means? That gives me 24. So, inscribed angle value, which is here, the value of x equals to 24 degrees. 24 degrees. Okay. Now, that is part one. Now, let me move my screen a little down. Now this time you are asked to find the measure of arc QR, which means measure of arc QR means, oops, let me use a different color, maybe green color, yeah. So you are asked to measure this one, the length of arc, okay. Please remember the angle made at the center by radii equals to the measure of the arc, right? So you are asked to find this central angle, okay, right. Now let me clear off this one. Okay, 180. Now let me imagine that there is another line which is joining QT. There is another line which is, now I see that a triangle is formed, right? And here an important point for you to remember is, you know that straight line makes 180 degrees. Agreed? So if this one is 180 degrees, if the central angle is 180 degrees, you know that what is the inscribed angle, right? Therefore, inscribed angle equals to half of central angle. Therefore, I know that here the central angle is 180 degrees. So half of 180, that gives me 90 degrees. Actually, there is a rule that angle in a semicircle is 90. Therefore, here inscribed angle value equals to 90. Therefore, this is 90 degrees. So I see that there is a triangle. Let me take this one. This is the triangle, right? I know that two angles of a triangle. One is 90 degrees and the other one is 50 degrees. So these are really easy calculations. One is 90, one is 50. What is the third angle means? Either you can guess or else you can write it separately, that sum of the angles of a triangle equals to 180 degrees. I think I'm messing it up a lot. So here, sum of three angles of a triangle, sum of three angles of a triangle is 180. I see that one is 90 degrees, the other one is 50, and what is the third angle? 90 and 50, that makes 140 plus the missing angle. We take away 140 on both the sides, so I get that the missing angle value equals to 40 degrees. Okay. Unfortunately, that's not the end of the story, because just now I got here the inscribed angle is 40 degrees. This is 40, right? But this is not the central angle. Please remember, central angle is double. I repeat, the central angle is double the inscribed angle. I know there are a lot of calculations and a lot of thinking here. I see that the central angle is here, the central angle is here, and the central angle is double the inscribed angle. Therefore, this is going to be 80 degrees. Due to lack of space, I am not showing. So if this is 80 means the length of arc, this is also 80. Okay. Next one is, let's say that a circle is given. First of all, you know that if 2 points are marked on this circle, and if a part of the boundary line is taken, this is called as an arc. Suppose if these 2 points are joined by a straight line segment, we call this one as a chord, right? And the area between a chord and arc, this is called as a segment. See the difference between sector and segment. In my previous classes, already explained what is a sector, right? Sector means the area enclosed between two radii and an arc. But here, area enclosed between a chord and an arc, this is known as a segment. This is known as segment. Why we are talking about this segment? Let me take say an angle formed. You please notice that the starting and ending point of this angle, okay, are same as, these are same as the starting and ending of the other angle. Do you see that both are having the same starting point and ending point? I repeat, I see that there are two angles which are in the same segment. If you want, you can experiment this one. Draw a circle. You may draw a segment and then draw angles, whatever the way you like. Let's say that I'm taking another circle and I'm drawing, say that this is an angle, and this is another angle. You don't bother about the shape of the angles, but make sure that both the angles are having the same starting point and same ending point. Okay, then you will find that measure of angle A and measure of angle B, these two will be same. These two values will be the same. For example, measure of angle A equals to say 50 degrees, and this one is also will be 50 degrees. In case 1, say that this is some 42 degrees and the other angle is also 42 degrees. Okay, so we say that angles on the same segment are equal. Okay, so let me give quickly a couple of examples. It's a straight question. The question is, what is the measure of angle F? Measure of angle F. This one. As I mentioned just now, I see that angle E and angle F, these two are having, say that GEH and GFH. These two are having the same starting point and same ending point, right? Or else, if you want, you may draw a segment like you draw a card and you see that this is called as segment. I see that both the angles are on the same segment. They are standing on the same segment, right? Therefore, your reasoning is angles on the same segment are equal. Therefore, angle E equals to angle F. Angle E value is 75. Angle F is also 75. Done. Questions? If you have any questions, you can email me. Let me go to the next question. A quick example. In this question, you are asked to find the value of x. Okay, I see that here this is the central angle. This is the central angle, and I know that this is the inscribed. This is the inscribed angle, right? Let me write the relation between, that is inscribed angle equals to half of central angle. Okay, any guesswork? In fact, you can plug in these values, but don't forget, observe carefully and write exactly where they are supposed to be. So here inscribed angle is 49. Do not take half of 49. It is 49 here, and central angle is missing, so half of x. You know how to eliminate this half. Just multiply by 2. So 2 times half, 2 times 49. 2 times half means that gives me 1. 1 time anything remains the same. So x equals to 2 times 49. So 2 times 49 is 98 degrees. Done. But all the questions may not be as simple as this one. So let me take this one. So here, please remember that the length of arc, the intercepted arc, is equal to the central angle. This is equal to the central angle. So don't get confused. If the central angle is not given, I know that inscribed angle is related to the central angle here. But if central angle is not given, what to do means, I know the arc length that is equal to the central angle. Therefore, this is going to be 100 degrees. And next, you know what to do. Let's write the rule again and again. That is inscribed angle equals to, it is half of central angle. So here central angle is given, so you have to plug in the values exactly. It won't go here. Central angle value you have to plug in here. So it is half of 100 degrees, that gives me 50. So that's the measure of the value of x, or I would say that that's the measure of the inscribed angle. The next question, see that the numbers are given the other way around. See that here 150 degrees, and next this is 100 degrees, and you are asked to find the measure of x. And we know that there is a relation between this inscribed angle and the central angle here, right? Central angle here. Then how to find it? Again, I'm repeating, you're asked to find the value of x. This inscribed angle is related with the central angle. So how to figure out the central angle means, can you find what is the value of this? The total angle in a circle is 360. And I know that this is 150, this is 100. So together this is 250. If I take away, I can find what is the missing length of the arc here. So that gives me 110. So if this one is 110, if this is 110, the central angle is also 110, right? Here onwards it's a cakewalk. Then let me write the condition again, which is inscribed angle equals to half of the central angle, Therefore, now let me plug in these values. It is half of, I know that central angle is 110. Just plug in here, you get that half of 110. That gives me 55 degrees. Any questions on this? Okay. Let me go back. Right. Here again, I see that you are asked to find the measure of the arc. Again and again, I'm repeating, please remember that the measure of intercepted arc is same as the measure of the central angle. So here I see that inscribed angle is given as 42 degrees and the central angle is missing. You may take it as x. So you know how to figure out. So far we discussed many questions. I'm sure you can figure it out. What's the value of the central angle? Then that is equal to the length of the intercepted arc. Okay, so let me quickly go to the next one. Here again, I see that you're asked to find the length of intercepted arc. There's a question mark here. Then how to figure out this one? So you have to figure out what is the central angle, or else there are two angles here, and can you figure out the third angle of I'm sure you can figure out the third angle of this triangle. Let me start writing that sum of three angles of a triangle, that gives me 180 degrees. So it is 49 plus 70 degrees plus x equals to 180. So 49 and 70, that is 119 degrees. Correct me if I'm wrong. Plus x equals to 180, and take away 119 on both the sides. You know how to isolate x. So the value of x equals to 61. But that's not the end of the story, because we are looking at the central angle. Now we are trying to find the central angle, right? So what is the relation So here is the inscribed angle I got, and we are looking for the central angle. You know that the central angle is double the inscribed angle, or else if you want to, you may write this way: the entire formula, inscribed angle equals to half of central angle. Half of central angle. Just plug in these values. I found the value of x, which is x means it is the inscribed angle. The value of x I found it is 61. Therefore, this value goes here. Therefore, 61 degrees equals to half of central angle. You know how to eliminate this half by multiplying by 2 on both these sides. So 2 times 61, 122 degrees. That's the central angle value. If it is 122 degrees, obviously the length of intercepted arc is also 122 degrees. Okay, so let's quickly summarize whatever you have learned in today's class. Point number 1 is if there is a circle and this is called as inscribed, this is called as inscribed angle, and this is called as central angle. And what is the relation means? The relation is if the inscribed angle is x and the central angle will be double to that, it is 2x. Or else I can say that the inscribed angle is half of the central angle. That is point number 1. And the second point is if you are given a circle and if two angles are standing on the same segment means both are having the same starting point and ending point, then we say that these two angles are equal. Okay, that's it from me for today's class. But one thing I advise you that you practice as many questions as possible, then only you can master the content. Learning math is just like learning swimming. I can teach you 100 techniques how theoretically how to swim. Unless you enter into the swimming pool, you can't master the skill. In the same way, math also, I can teach you 100 problems. Unless you practice some problems on your own, you can't master the skills.